Welcome to aminacademy.com. In engineering thermodynamics, let us discuss about properties of pure substance. What is a pure substance? A pure substance is a system which is homogeneous in composition and homogeneous in chemical aggregation and invariable in chemical aggregation. Homogeneous in composition means that the composition of each part of the system is the same as the composition of every other part. Composition means the relative proportion of the chemical elements into which the sample can be analyzed. It does not matter how these elements are combined. A substance that has a fixed chemical composition throughout is called a pure substance. Now, further discussion about pure substance. Pure substances are substances that are made up of only one kind of particle and have a fixed or constant structure. Pure substances are further classified as elements and compounds. An element is a substance that consists of only one type of kind of an atom. An element is a pure substance as it cannot be broken in down or transformed into a new substance even by using some physical or chemical means. Elements are mostly metals, non-metals or metalloids. Compounds, on other hand, are also pure substances when two or more elements are combined chemically in a fixed ratio. However, these substances can be broken down into separate elements by chemical methods. Characteristics of and properties of pure substances. Pure substances are mostly homogeneous in nature, containing only one type of atom or molecule. These substances mainly have a constant or uniform composition throughout. The substances have fixed boiling and melting points. A pure substance usually participates in a chemical reaction to form a predictable products. Examples of pure substances. All elements are mostly pure substances. A few of them include gold, copper, oxygen, chlorine, diamond, etc. Compounds such as water, salt, or crystals. Baking soda, amongst other, are also grouped as pure substances. Now, what is phase change of pure substance? Here, we'll discuss about the few phase change of a pure substance. As a water is heated slowly, its temperature rises until the temperature of the liquid water becomes 100 degrees Celsius. During the process of heating, the volume slightly increases as the heat increases. The temperature specific volume diagram is given here. During the phase change of the pure substance, the temperature of the substance remains constant because the energy provided will be utilized in weakening the bond during solid to liquid and liquid to gas transition. Look at here. Here, every stage is given for solid state, solid warming process, saturated solid, melting, boiling, vaporization, all different stages is there. A PT diagram can be constructed for any pure substance. The line that separates the solid and vapor called phases is called the sublimation line. The line that separates the solid and liquid phase is called a fusion line. The line that separates the liquid and vapor phases is called vaporization line. All these points meet at one point, it's called triple point. The temperature pressure diagram, it shows the PT diagram, that is pressure temperature diagram constructed for pure substances here. Next, PVT, pressure volume temperature surface. It's a three-dimensional surface. The PVT surface of a pure substance is shown in the diagram. Here volume, pressure and temperature is given here. The equilibrium states of a simple, compressible and substances can be specified in terms of its pressure, volume and temperature. The PVT surface above represents the substance which contracts upon freezing. Next, phase change of pure substance. Phase of a pure substance. A pure substance may exist in different phases. There are three principal phases: solid, liquid and gas. A phase is defined as having a distinct molecular arrangements that is homogeneous throughout the separated from others by easily identifiable boundary for phases. Here, gas, this is a liquid, this is a water, this is a solid state here, liquid and gaseous area here. This point is triple point here. Phase change definition. Saturation temperature. What is saturation temperature? Saturation temperature means a boiling point. The saturation temperature is the temperature for a corresponding saturation pressure at which a liquid boils into its vapor phase. The liquid can be said to be saturated with thermal energy. Look at here. Here, boiling point for some cases is 87. Boiling point for water is 100. Boiling point for some other closed container, its boiling point increases because pressure is trapped. That is, pressure is also increased here. Next, compressed liquid. What is compressed liquid? A compressed fluid or liquid, also called a compressed or unsaturated liquid, subcooled fluid or liquid, is a fluid under mechanical or thermodynamic conditions that force it to be a liquid. Next, saturated liquid. Saturated liquid, a liquid that is about to vaporize at 1 atmosphere and 20 degrees Celsius approximate. Water exists in a liquid phase, that is compressed liquid, at 1 atm, 1 atmosphere pressure and 100 degrees Celsius. Water exists as a liquid that is ready to vaporize, that is saturated liquid. Now, saturated vapor. Thermodynamics, a vapor whose temperature and pressure are such that any compression of its volume at constant temperature causes it to condense to liquid at a rate sufficient to maintain a constant pressure. At a constant pressure, vapor condenses as a liquid. Dry saturated steam. A dry saturated steam refers to a partially condensed from a water that occurs at the temperature and pressure where water vapor and liquid water can coexist. Water vapor and liquid vapor. That is, water vapor and liquid water can coexist is called a dry saturated steam. Such conditions accelerate the corrosion rate of surrounding metals. Next, wet vapor. When water is boiled, the water evaporates much faster and makes steam. Steam often has droplets of water, which is what is seen. Water is boiling. Since both water droplets and water vapor are present, this is called wet steam, also called wet vapor. This wet steam area in the chart, it is a wet steam area is here. Next, superheated steam. Superheated steam is a steam at a temperature higher than the vaporization point at the absolute pressure where the temperature is measured. This is a superheated steam, this area here. Degree of superheats is the number of degrees a vapor is above its saturated vapor temperature, that is a boiling point, at a given pressure. For example, water boils at 100 degrees Celsius, atmospheric pressure, water boils at 100 degrees Celsius. If the steam is at 105 degrees Celsius and it has 5 degrees of superheat. That means under a pressurized conditions, if water is heated, we can get a superheated steam when it flows out. So far, we discussed about some definitions about the phase changes, as well PVT diagram, PT diagram, as well pure substances and its characteristics. We have done. Please subscribe our YouTube channel.